Hi students, welcome back to my channels. In today's episode, we'll continue our exploration of straight-line forms, focusing specifically on the standard form of straight lines. In our last episode, we covered various forms of straight lines and learned how to use the appropriate formulas to derive their equations. These formulas are summarized in the table. Among them, the standard form, or simply call it general form, serve distinct purposes. As mentioned previously, we express answers in standard form to facilitate communication and make it easier to verify our solutions against the textbook. However, the standard form has additional functions that we will explore in this episode. Let's start with the formula for standard form. After arranging some terms, we can compare this expression with the slope-intercept form, which is y is equal to mx plus b, where m is the slope and b is the y-intercept. Equating the coefficients, we can find that the slope m is equal to negative a over b, and the y-intercept b is equal to negative c over b. It is important to look that these two relationships can be memorized as formulas. In fact, these formulas provide convenient tools for determining the slope and y-intercept of a straight line, which will be very useful when tackling some complex problems. In question 1, we need to determine whether the given pair of lines are parallel or perpendicular. To do this, we simply check their slopes. However, before we start to do the exercise, we need to know some facts about the slope of parallel lines and perpendicular lines. Let's look the slope of the two lines are m1 and m2 respectively. The slopes of them are equal, that is m1 is equal to m2. Then these two lines are parallel. If m1 is equal to m2, then line 1 is parallel to line 2. If we know that the product of the slope is equal to negative 1, then the result is that L1 is perpendicular to L2. We can use these relationships to solve question 1 efficiently. We just learned that the formula for slope is negative a over b. Now we can apply this formula on line 1 and line 2. The slope of line 1, m1, is equal to negative 3 over negative 4. So that is 3 over 4. For line 2, once again, we apply the formula negative a over b. That is negative 6 over h. That is equal to 3 over 4. And we see that because m1 is equal to m2, so we can say that L1 is parallel to L2. In part B, we still use the formula to find their slopes. For line 1, M1 is negative 5 over 10. That is negative 1 over 2. For line 2, we see that A is equal to 1 over 2. B is equal to negative 1 over 4. So for line 2, the slope is tip 1 over 2 over negative 1 over 4. As there are two fractions, so it is not a good way to write these expressions. We use the division sign rather than the line. Okay, so we write again negative 1 over 2. That's negative a over b. B is negative 1 over 4. So negative 1 over 2 times interchange the numerator and the denominator, become negative 4. So the answer for this one is 2. Now we see that the product of them is equal to negative 1 over 2 times 2. The result is negative 1. As we just mentioned, if the product of two slopes is equal to negative 1, then these two lines are perpendicular lines. So it comes to the conclusion L1 is perpendicular to L2. In question 2, P is a point on a straight line L. In part A, we are required to find the value of H. In part B, find the slope of L. These two parts are easier, so we finish them first. Okay, as we all know that if a point lies on a straight line, we can simply substitute the point into the line. The left hand side and the right hand side will be equal. Okay, so in part A, we put PH4 in L. Okay, so 5H minus H minus 2 is 0. So 5H is 10, so H is 2. Okay, in part B, the slope of L is equal to negative A over B, so negative 5 over negative 2, so 5 over 2. Okay, part C, find the equation of straight line passing through P and perpendicular to L. To better understand the questions, perhaps we draw a diagram. As we just found out that the slope of L is 5 over 2 and pass through the point 2, 4. So perhaps we draw a diagram like this. Pass through a point 2, 4. So P maybe here. 2, 4. And slope of L is 5 over 2. So the direction of the line should be like this. Should be this way. Okay, this one is the line L. The question asks us to find the equation of the straight line that passes through point P. Okay, passes through this point and perpendicular to L. So the required line may be like this. Okay, perhaps we call it line 1. These two lines are perpendicular. So we can see that the product of these two slopes is negative 1 because they are perpendicular. So we know that M1 is negative 2 over 5. To find the equation of line 1, we have the point 2, 4, and we have the slope is negative 2 over 5. So we can use Poinsot form. Y minus 4 is equal to negative 2 over 5 times S minus 2. 5 move to left hand side. And minus 24. Okay, this line is the required line. Next question. In the figure, the straight line L cuts the x-axis and the y-axis at A and B respectively. In part A, we are going to find the coordinates of A and B. As we have learned how to find the x-intercept and y-intercept in previous episode, so I have done the step of part A. Okay, assume that the coordinates of A are A0. The coordinates of B are 0, B. As these two points lie on L, so we can substitute these 2 points in L. So we have the answer of A is 4 and the answer of B is B. The answer A is equal to 4, 0 and B is 0, 3. Okay, in part B, find the area of triangle OAB. Triangle OAB is this triangle. This triangle is a right angle triangle. We know that the base is equal to 4 because the coordinates of A is 4, 0. Okay, so the base is 4. Similarly, the height is 3. In part B, area of triangle OAB is equal to base times height divided by 2. So there is 6 square units. Okay, in part C, hence find the shortest distance between the origin O and the straight line L. Before we continue, we will need to clarify the meaning of the shortest distance. Now suppose that there's a river and it is the river bank. Suppose that you stand here. Okay, if you want to find the shortest distance to walk to the river bank, will you walk in this way? Will you walk in this way? Will you walk in this way? Okay, no, you will walk straight to the river bank. The angle here should be 90 degrees. Okay, it is according to our daily experience. We know that. Okay, so the shortest distance from the origin to the line L should be the perpendicular directions. So perhaps we draw a line, perpendicular line. Now suppose that the distance, we call the distance is K. Okay, to find the value of K, so far we don't have a particular formula to find the distance between a point to a line. Okay, we don't have this kind of formula. Don't have any formulas to find the distance, but the question has part A and part B and part C, so all the parts should have some relationship, right? Okay, in part A we know that the coordinates of A and B. In part B we find the area of triangle OAB. So to find the value of K, should use the answer from A and B, right? Okay, now to find the area of triangle OAB, there should be 2 ways to find that. Okay, one way is the base times height, so we know that in part B is 6 square units. Okay, but we can look at the triangle OAB in different way. Okay, we can see that as the base is AB. Okay, AB is the base, then the height is K. The length of AB is quite straightforward, as we have the coordinates of A and B. We can use the Pythagoras theorem to find the length of AB. AB is equal to square root 3 square plus 4 square. So AB is 5 units. Okay, so the area of triangle OAB should be equal to 5 times K divided by 2. We already know that the area is 6, so we can relate 5K over 2 to 6. Okay, so K is equal to 12 over 5, so K is 2.4. Okay, so we can answer this part, the shortest distance is 2.4 units. But before that, of course, we need to assume that the shortest distance BK. Okay, in question 4, A is greater than 0 B is less than 0, C is greater than 0. Perhaps I will write the sign of ABC. A is positive, B is negative, C is positive. Okay, which one of the following is the graph of AX plus BY plus C is equal to 0? Perhaps we consider the slope and y-intercepts of the equations. Okay, slope is equal to negative A over B. In this straight line is negative A over B. As just mentioned that A is positive while B is negative, so negative A is positive, B is negative, so the result is positive. Okay, so we can cross C and D. Why? Because for line C and line D, the direction of the line is this way. Line have negative slope, so that's why we can cross out C and D. Now we try to find the y-intercept. Should be equal to negative C over B. Okay, once again, C is positive, B is negative, so the y-intercept is a positive number. We consider the y-intercept. Okay, the dots are the y-intercept. Okay, so obviously B is the answer because the y-intercept is above the x-axis. Okay, so the answer of this question is B. Okay, last questions. Straight line is perpendicular to 3x plus hy minus 11 is 0. If the y-intercept, it should be the y-intercept of L is 2. Find the equation of L. We have two straight lines. One of them is L. The other is given by 3x plus hy minus 11. Okay, we can use the formula to find the slope. The slope is equal to negative 3 over h. The slope of L is obtained by, because the product is negative 1, so negative 1 divided by negative 3 over h, so it will become h over 3. Okay, now we have the slope is h over 3, and we have the y-intercept. We can use the slope-intercept form, which is mx plus b. So y is equal to m is h over 3s plus the y-intercept is 2. So 3y is hs plus 6. S is minus 3y plus 6 is equal to 0. So the answer is D.